morning. In this video, we are going to discuss proposition 6 from book 2. So this proposition states that if we are given a straight line, for example AB, and it is bisected at a point D, and then if we produce this straight line to point C, and then we will have this equality. So the square of the whole by the extended part, which will be the whole will be 2a plus b by the extended part b, together with the square on the half, which will be a square, will be equal to the square on the half plus the extended part, which will be a plus b squared. So let's go to prove this equality. So first of all, please recall proposition 46. If we are given a straight line, then we are able to construct a square on it. So let's construct a square on CD. Okay, so we assume this is S, this square, sorry. And then let's use postulate 1 to construct a diameter of this square by connecting these two opposite endpoints. And the next step is recall proposition 31. We are allowed to construct a straight line through a point which is parallel to another straight line. So let us construct this straight line through point B that is parallel to this side of the square. And then let us use this proposition again to construct a straight line through this point that is parallel to AB. Okay, so this is parallel to AB, and let's use this proposition again to construct a straight line through point A that is parallel to this side of the square. So in proposition 4 and proposition 5, we have already proved that in this shape, this is a rectangle, let's call it R1. This is another rectangle, R2. This is rectangle, R3, and this square, S1, and this, the bottom side is square, S2. Okay, and let's just write the whole square as say A, B, C, E, F. Let's say square S is FC. Okay, so we will just skip the proof steps of these rectangles and squares. And if we have a look at this square, we will know that R2 will be equal to R3, correct? Because recall proposition 43, two complements of a parallelogram about the diameter are equal. So this is a parallelogram, of course, because it is square, and this is diameter, and R2 and R3 are two complements about the diameter, so they are equal. And recall proposition 36, if two parallelograms have the same base and they are in the same parallels, then they are equal. Okay, so these are two parallels, and R1 and R2 have the same base because D bisects AB. Okay, so the base are A, so they are equal. And we know R1 equals R2, and combine them and use common notion 1, we know that R1 will be equal to R3, correct? And let us add both R2 and S1 to both sides of this equality. Then we have R1 plus R2 plus S1 will be equal to R3 plus R2 plus S1 because of common notion 2, right? We add the equal things to two equal things, the results are also equal. And the right side can be written as a nomen, so please recall what a nomen is. These three parts about a parallelogram is so-called a nomen. So let's write it like this and call it as G. So this is a nomen, so we know that R1 plus R2 plus S1 is equal to G. Okay, so what is G plus S2? So knowing the three parts of this parallelogram, so if we add the fourth part, which is S2, then it will be the whole parallelogram. In this specific case, it is squared. So let us add S2 to both sides. Then we have R1 plus R2 plus S1 plus S2 will be equal to G plus S2. And this is a square, right? So it is S square here, FC. And the left side will be, let's check, R1 plus R2 plus S1. It is a rectangle contained by the whole and BC. So it will be rectangle, let's make it EFH. It will be rectangle HC plus S2 will be equal to, the right side will be S. So let's try to express them in algebraic form. So the square HC is equal to 2a plus b times b, because this is square S1, so it must be equilateral, so this is b. So it is the whole 2a plus b times b is square, okay? And S2 will be a square, because this is a rectangle, so opposite sides are equal, so this is a. Similarly, we can prove this is a and this is a, and this is also a, this is b, opposite sides are equal, okay? Will be equal to the right side, S. The side of S is a plus b and d, so the S will be equal to a plus b squared. And this is the proposition or the equality we're trying to prove. So we have proved proposition 6 from book 2. In the next video, we are going to discuss proposition 7. Thanks for watching. Have a good day.